Welcome to my series on intermediate Java topics. Today we're going to talk about inheritance and why it's important. But first, an acknowledgement. The examples discussed in this slide deck come from the book Objects First with Java. This book was written by David Barnes and Michael Kohling. It's a great book that describes the principles of object orientation from a design perspective. So this window looks like a social media application that lists posts about traveling. Some of the posts are simple message posts. Some of the posts are photo posts. For example, this first post here just has a message. Next time I'm going back to Hawaii, I'm skipping Oahu. We get to know the author of the message, Stella Robbins. We see the date it was posted, and we see how many likes it had. So the other thing we can do for every post is we can have one or more, or 0, added comments to the post. So that's how that works. You can see there's another one right below. There's a post right here from Mary Downey. And these are examples of simple message posts. Now here we have something a little bit different in this area. In this area we have a photo post. This post has a picture, as you can see. It has a caption, which is a little different from a message, but it has some things that we're familiar with. It has the date and timestamp of the post. It has the number of likes, and it also has a series of comments. Here we see UML class diagrams that show us the information about both of these classes, the message post and the photo post. One of the first things you will notice is that each of them have a top section, and the top section of a UML class diagram is used to identify the fields or the instance variables. So we have usernames, we have messages, we have timestamps, we have likes and comments over here. And in the photo post, we have username, file name, caption, timestamp, likes, and comments over here. These reflect the different instance variables for the two different classes. A couple other things you might notice. You might notice that every instance variable has a data type. Usernames are strings. Captions are also strings. The likes is an int value. The comments is an array list of strings. So UML class diagrams will show the data types of the instance variables. The other thing that you will see are these hyphens in front of each field. The hyphens indicate that the instance variable is private. The other part of the UML class diagram is down here. And these parts describe the methods of the class. So again, every method has this symbol in front of it. These all have a plus sign. The plus sign means that the method is public. Also, the methods are identified with their return type. So if I like a post, there's no return. It's a void method. Also, if I unlike a post. Other methods have different return types. For example, the getText method has a return type of string. The getTimestamp method has a return type of a local date time. These reflect the data types of the corresponding instance variables. Finally, for the method part of a UML diagram, you will notice that the parameters for the method are also documented. Now, like doesn't need any parameters, so the open and close paren have nothing inside of them, but add comment does. Add comment needs to pass a parameter, it needs to pass a string to represent the text of the comment. So now you have an understanding of UML class diagrams and how they work, And please examine this and tell me what you think about these two different class diagrams. There seems to be a lot of repetition. We might solve that problem with inheritance. So let's look at this repetition between the two kinds of posts in more detail. You'll notice that both the message post and the photo post have a username. They both have a timestamp. They both have the number of likes. They both have a list of comments. So that's what the two classes have in common. Where are the differences? Well, the message post has this string called message. The photo post has the file name of the photo and a caption for the photo. Similarly, if we look at the methods, we see again a lot of similarities. We have like, unlike in both. You can add a comment to both. Both of them can have a getter method or an accessor to get the timestamp. And both of them allow you to display. Again, what are the unique differences? The message post has a method to get the text of the message, which corresponds to the instance variable above, and the photo post has two getters, getting the image file and getting the caption. So what we really have here, the only differences are in the two different instance variables that are between message post and photo post and their corresponding getter methods. This is going to cause a lot of problems for us in design, which we'll see next. So what is the price for all this duplication? Well, the price is duplicate code. We're going to have to declare and initialize our instance variables between the message post and the photo post, and they're identical. So we'll be doing the declarations and the initializations in both classes. That's duplicate code. Even worse, we have methods. The methods are going to help us do certain things like display. And the display method is going to have to be written again twice, once in message post and once in photo post. Do we really want to duplicate all this code? And the problem is, if we have a bug or a problem in the code, now the code's in two different places. This is terrible design. The other issue that comes up is, do we really want to have separate collections for each kind of post? Every time I loop through a collection, I'm going to have a collection of message posts and another collection of photo posts? That seems excessive. I mean, after all, they're both different kinds of posts. Why can't we just have one collection rather than trying to do everything twice in two separate collections? And this will manifest itself in how we're going to add posts. You have to add a post to either the message post list or the photo post list. You have to, when you want to display the post, you have to go display all the message posts and display all the photo posts. Seems like a lot of work, seems like a lot of redundancy, and it is. But there's even more problems with having two separate array lists, one for message posts and one for photo posts. And that is, likely when we're doing our website, our travel diary, we're going to want to go through the collection in order of time. So here we have two message posts that were done, followed by a photo post, followed by a message post. How are we going to loop through two different collections and make sure that we display them in chronological order? And it's two message posts, then one photo post, and then another message post. If only there was a way that we could have a single collection and store the two different kind of posts in that collection. The good news is we can. Here we see the solution for our problem. The solution is to create a superclass, a new class called post, And this class will contain all of the instance variables that were in common between message posts and photo posts, and it will also contain all of the methods that were in common between the two subclasses. So we're going to call post the superclass. We're going to call message post and photo post the subclasses. These subclasses will inherit all the fields from the superclass. This means that a message post, as its instance variables, will have the username, the timestamp, the likes, and the comments. It will pick those up from the superclass, but it will also add a unique instance variable of its own, message. Similarly, the photo post will pick up the 4 common instance variables from its superclass, post, and it will add its own unique attributes, its own unique instance variables, the file name, and the caption. And similarly, the message post and the photo post will have their own unique methods, and they will inherit all of the common methods from their superclass post. This is nice because all of that common code can now be written once, and it's written inside the superclass post. So again, the superclass is going to define the common instance variables and methods, and the subclasses will inherit these attributes, and they will inherit these methods, and they can add their own if they like to. Also, you will notice in terms of UML, the way to draw this is to have an arrow. The arrow points from the subclass to its superclass, to its parent. And these types of arrows are called generalization arrows in UML. And what it says is that post is a more general version of a post. It's generic, it's higher level, it's a post. And a message post is a post. And a photo post is a post. And those generalization arrows that you see are often read as is a. Message post is a post, photo post is a post, and now we have solved our code duplication problem, and we've seen how to model this in UML. Now we have to look at our subclasses, and specifically how to make instances of them. But first, let's look at our superclass, post. Post will have declaration statements for all of its instance variables, as we've seen before. And in the constructor, it's going to take in one parameter. The parameter it takes in is a string for whoever authored the post. Now let's take a look at what the constructor does. The constructor takes the author and assigns it to the instance variable username. However, for the timestamp, we don't need to take in any parameters. We're just going to set the timestamp to be the current date and time. And we can get the current date and time from the local datetime class. There's a static method there called now. So that's how we're going to handle that. In terms of the likes, when we first begin our post, no one's liked it yet. We're going to set that to 0. And of course, there's no comments yet, so our comments is going to be an empty array list of strings. So as you can see, the only thing our constructor needs is one piece of information to fill in the username field. Okay, now let's go over to the subclass, and we'll start with message post. The first thing you'll notice is that message post extends post. This is the language we will use to say that a subclass inherits from the superclass. That's what the extends word means. And then post, of course, is the superclass. Okay. Now, in terms of instance variables, we only need to declare the unique one. That is the string message. All this is good. Now, let's talk about the constructor. Here's the constructor. And notice that the constructor takes in two parameters, a string for the author and a string for the text of the message. What we want to remember with subclasses is that we want the constructors to use the fields that they own. In other words, we know that the post superclass is responsible for all of those fields. So we're going to want the superclass to take care of its own field. So because the superclass has the field username, we have to pass it to the superclass constructor. We do that by using the method super. What super does is super looks for a constructor in the superclass that will accept the method signature. So it's looking for a constructor that is going to be taking in one parameter, a string. And it finds it. When we call super with a string, this is what we're going to be running. So when you build a constructor for a subclass, the thing to remember is always take care of your superclass fields first. After we do that, then we can initialize our instance variable for our unique field, the message. If we look at photo post, it does the same thing. Our constructor here takes in three fields: the author, the file name, the caption. And because, again, the superclass is going to take care of its own field, the username, we will pass this author to the superclass constructor. And after that, we will take over and do the initialization of our own instance variables. So this is how constructors will work with subclasses and superclasses. A few more words about constructors. Constructors are not inherited. Constructors are the only type of method from a superclass that the subclasses will not automatically pick up. Therefore, your subclass constructors must always explicitly invoke the superclass constructor. They must always contain a call to super. And this call to the superclass constructor must always be the first statement in your subclass constructor. Now, what's interesting is that a call to super will be created in the compilation of your Java, even if you forgot to put it in. Let's take a look at the two classes below. We have a class called Subclass that extends the superclass. And the subclass constructor does nothing but just print out, this is the subclass constructor. On the right-hand side, we have the superclass. And its constructor just prints out, this is the superclass constructor. So what happens if I make an instance of the subclass? There's no call to super. You might think it just will print off, this is the subclass constructor. But look what happens. The output is below. When I make an instance of the subclass, the superclass constructor is called, even though I didn't ask for it. Interesting stuff, right? Finally, there's something else to know about super. If you just call super with open parens and parameters, you're going to be invoking the constructor of the superclass. But you are allowed as a subclass to run any method of your superclass. And the way to do that would be to put super dot the method name and pass the arguments. So it's really important to know that subclasses can call the superclass constructors, but they can also run any method of the superclass using super.methodName. One last thing. Let's talk about how we were going to be adding posts. Our inheritance has made our lives so much easier because originally, when we only had the two classes, message post and photo post, we had to have two different methods. One method, add message post, to add a message post, and a second method called add photo post to add a photo post. Notice that each of those two methods pass the parameter of the individual type of object, the message post or the photo post. That's why they were different. But now we can change it up. Now we can just have one method to add a post. And we can add a post that's either a message post or a photo post. The way we do this is our new method just says add post, but look what it takes as a parameter. The method is described with the post as a parameter, the superclass. So what does this mean? This means I can call the method add post and pass it any legitimate post object. Well, what is a legitimate post object? Obviously, an instance of post, but also an instance of its subclasses, also a message post, also a photo post. So when I can do this, this is called substitution. And substitution just says that whenever I have a call to a method and I need to pass it the superclass, I can also pass it an instance of the subclass. And the reason for this is simple. Remember our UML diagram with generalization, and we saw those arrows pointing to the superclass from the subclass. And we said those arrows meant is a. That's how we read them. So because a message post is a post, and because a photo post is a post, I'm allowed to call the add post method with any instance of the superclass or any instance of the subclasses. This concludes Inheritance Part 1. Thanks for listening.